So, good afternoon, everyone. Let's start with a question. Who knows the movie Memento? You've seen that one? Very good. I've seen one hand over here. So that's great. Memento, it's a must-see, I have to say. It's a movie that's famous because of the structure of the movie. The movie is played or recorded in a reverse chronological order. So it starts with the end, and during the film you learn what actually has happened. It's about the main character that is suffering short-term memory loss, and he tries to solve a mystery. And that's actually what we are going to do as well today, because we are two presenters and we also suffer a kind of short-term memory loss.
Which might or might not have something to do with last night. No further comment.
Yeah. So we have a Java Spring app. It's a app that says greetings from Teno application platform to DevOps. We don't know where it's coming from, but we will try to solve that today. So we will present in a reverse order. So the first slide of today is thank you for coming. Are there any questions? If not, we are ready to start, right?
Yeah.
So
go for it.
We will start with a demo. Big part of our presentation is a demo. So David, what do we see here?
Yeah, so as with all of us, our hard work and education culminates to a beautiful app that screams greetings at you from the browser. It'll be interesting to see how we got here. The only thing I do remember was, besides the app, that there was something like a developer platform or a developer portal.
I think that's this one, right? Or not?
That had something to do with how this application came about. Yeah. So, and this is something we need, right? Maybe we can puzzle back which application.
Well, we see here a long list, and there is our NL Tansu Java web app, because that's the name, I think. That's what we saw. So let's click on that. And what do we see here?
Yeah, let's see. So, I see there's a link to source code. That could be a good first hint towards what this application actually is.
Let's click that.
So where we go? Okay, we get into GitHub. I believe this is a relatively standard. Is it a Spring app? Yes. I see a pom.xml. We can probably open it, and we will see it's not the most new Spring app in the world, but it's a Spring app, known and loved by all. There are a couple of weird files there. I see a tilt file, I see a config dir, and a catalog dir that I don't see every day, but probably we'll get to what that actually means. Yeah.
Let's get back to the interface. Maybe we see something else. So we have some links here in at the bottom.
Yeah, we might say, okay, production link. If we click that, same app. Okay, so, all right, and of
test
course,
app.
There's also a test version of this app, apparently. Yeah. So how did we actually get this app into this platform? How did this actually get deployed?
So maybe people know. Some of you know Backstage, pretty popular initiative, and this is actually based on Backstage, what we're looking at right now, right? So we're going to explore the interface a bit more to see if we can learn what is this app about, what is it doing, who is using this actually. And we see here the owner of this app, and the owner of this app is the Dutch team. We are both from the Netherlands. So let's click that, and then we get some more information of the team that is involved in working on this specific application. So you're there, your name is, this is David. And
so, I'm David.
I'm there as well. My name is Victor, very good. And our other colleague who's not here today, his name is Niels, is also working on this app. So we get some information from the interface here about the application, what's going on, who's owning it, some important links here as well, very nice. And normally you would also have some documentation available. And in this case, we don't have the documentation available for this app, but I have another environment available that's over here. And there is in this case, a app that's built in Go, and this has tech docs, technology documentation, and this provides some information on who's working on the app, how can you start contributing, etc., etc. This documentation is coming from a Git repository and is integrated into the platform, so it's very easy to new employees to get onboarded and use the app and start working on it, right?
Yep.
That's what we see here. So apart from that, let me check. So we have seen the teams, we have seen the documentation, we know there's an app. Can we also learn maybe what kind of app this is? Where is it running on? Maybe I see here a tab called Runtime Resources.
Mhm.
So we have our app, Runtime Resources. Let me click here. And the next thing we see here, if we click deployment, that
So
this is, actually this looks like a Kubernetes application.
I think it's running on Kubernetes.
It's Kubernetes, yeah.
Well, everything is running on Kubernetes
Nowadays,
these days,
right? Yeah, of course.
Yeah.
So what we see here, again, this is based on Backstage. We see the hierarchy on the right side of this application, all the different objects that are linked to our application. In this case, we are looking at the deployment. We can scroll down, and we also see the pods. The pods that, in this case, the pod that is running the application. You see it's here, over there, and I can click that, and we have live view. What's that, David? Can you tell a bit more about live view?
So it's always good to have a little bit of insight into the running state of our application. And for the people who have been using Spring over the years, they might recognize that there might be some link towards the actuator, the Spring actuator, which gives runtime information. All the different kinds of runtime information. Apparently, this platform exposes. In a convenient way, you have an idea about log levels. You can actually at runtime change log levels. You can make a thread dump if needed. It's not full observability, but you can, for instance, have a look at if you do the drop down. You can, for instance, have an idea of latest requests that were sent to this pod. You can see, you can inspect your beans. If you need to find something, you can get basic metrics that have been exposed automatically by Spring itself. And on the whole, it's a first step towards having an idea how your app is behaving in production. As stated before, it's not a full observability platform, but at least you have a good grip on how healthy or how bad the application is doing.
Okay, very good. So we started with this application. We didn't know much about it. We logged on to this solution Teno application platform.
Mm-hmm.
We see the Backstage interface, and we got a lot of information about our application, where it's coming from, who's using it, what it's doing.
How it's happening at runtime.
The question we haven't answered until now is, how was this app built?
Yeah.
So maybe we can get some information about that, right?
In the words of the talking heads, how did I get here?
Yeah, exactly. So here we have this option, the workloads, and we see our app. And you see here the app that's running in namespace dev. So that's the Kubernetes namespace dev. That is the, let's say, between quotes, it says dev, but it's our production workloads.
Mm-hmm.
Okay. And we have the Victor iterate namespace as well. So 2 instances there. Let's open one of them. And then what do we see here, David?
Well, first we maybe look at the end, as this is a bit of the theme of our talk. Apparently, there has been a delivery and of the application and a component that pulled the application from a repository or from Git. So this is obviously a GitOps deployment. But how did we actually get to the point where we? Where we have a running container and working Kubernetes configuration. I haven't been around in the Kubernetes space too long, so I don't know how to. I don't want to add all of these things. Let's see how we got here. So one thing is, so the first step is how did we get the source? So this is FluxCD doing its work. It's pulling the source code from the repository, as you can see here, and it's polling for changes. So every time that we do a commit to the right branch, in this case main, this supply chain will be triggered again.
So I guess this is a kind of a path to production we're looking at right now, or not?
Yeah, you might even say a golden path to production.
There you go. Yeah.
Yeah, we had to. So we have the source code now, and how do we get to the step of a container? So the next step here is the image provider. So there are different ways to go about this, but by default, this is implemented by the Tanzu build service, which is basically based on cloud native build packs that have a long history from Cloud Foundry days, from Heroku days, and that industrialized the way we build containers. So there is no Docker file involved and not needed. So the build service takes your source code, analyzes the source code, creates a base OS and creates the right middleware for the code that you're pushing to it. This is a polyglot platform. We are now pushing a Spring app. So at that point, it knows it has to build a Java container, has to get a Java runtime from someplace, which we can actually inspect in the log. All right. So, for instance, there are several phases towards making an automated container. First, the access to a repository is checked, and there's some analysis going on. But then, looking at the source code, which build packs are we going to run? And this is here we add like a lot of things that otherwise, when writing a Docker file, would make life more complicated. So there are all kinds of automated ways to, for instance, insert custom CA certificates, an automated build pack in an automated way to create a software bill of material. We see that our Java runtime is being pulled into the container. We see there are specific provisions for instance, Maven or Spring Boot. We see that we are that we're adding a build pack that does something to add custom labels. And in this case, so this is the first run of this build service. In the next time it runs, here we will restore layers that have been created before. So the build packs also take care of the right way of layering. The way we build containers has become more and more sophisticated, more and more security practices, and the build service automatically takes care that all of those are done. So then we get to the point where we do the actual build. So ultimately, so the build pack consists of two parts. There's a container that actually builds your code, so that has all the facilities to make a Maven build in this case, or a Gradle build. And then at runtime, we create a container that has only the minimal information to actually run it. So here we have the Maven build. And at the end of this process, we have a running container. We have a container built and pushed to a container registry. So this is, so this is a big advancement because this achieves a couple of things. Like if other teams are now pushing Java apps and using this same supply chain, we are sharing the same base OS, we are sharing the same version of the middleware. If one of those layers turns out to be to have a vulnerability or a CVE, we can update them in a very efficient manner. We automatically know which applications are affected, all affected applications will be replaced, will be rebuilt, and a new container will be generated. So in this case, this supply chain can be triggered by a source code change, but could also very well be changed by an update in the base OS or an update in the Java version of the build pack. So that no matter what, we always know that the application is in the right end state. So next steps that we see here is a config provider. That's a component that basically adds a lot of the boring bits of the Kubernetes YAML hell, right? So we can codify a lot of standards for all the different types of apps on the platform. So labels that we need that are dependent on the language that we are using or the frameworks, all kinds of other conventions that we need to have like a well-behaved app, things that are specific to Spring Boot, but also maybe other conventions that you want to encapsulate. And all the apps that have been started, that have been built on this platform will contain the right conventions of your organization and will deploy it in the right way. Other components that are in this supply chain are, for instance, service bindings. So this app is just an Hello World app, but if it would depend on, for instance, a data service, here you could do a claim when you declare the application, you can do a claim of a certain service type, and the platform in this step will fulfill that claim, will make sure that there is a database instance or a RabbitMQ instance or whatever you're asking for, and inject the credentials and the location into the application so that the application developer doesn't need to know about where it lives, what the credentials are, and in every different environment it will get fulfilled in the right way for that environment. So other steps in this process are things like API descriptors. So if you have, for instance, Swagger or some other component that describes your public API, it will be picked up by the platform and published in the portal so that you can reference other people's public APIs and have immediate live documentation of your app. And ultimately, all these steps are the result of all these steps is written to a Git repository, as we saw before, and then deployed. So there are a couple of steps here. This is a very rudimentary pipeline. A real path to production will at least involve some security steps. Leading up to this presentation, our good friend Robert in Denmark deleted our container registry, so we spent the whole day getting this stuff back together. So we have to switch to the other environment to show you the security steps in the supply chain.
Yeah. So this is again a very basic supply chain, or the path to production. What you see here, building the container, generating the Kubernetes artifacts, and that you can deploy to your Kubernetes cluster. Of course, and this is another example of a supply chain, and this has more steps, right? Because what we're now adding here is what we call testing and scanning. So we're adding some extra steps here. So we see here the source tester step, where we use, in this case, Tecton, to test the application and to see if we got the result that we are expecting here. So that's something we can do. And we can also do source scanning. So we can also scan the actual application. In this case, the app is called Insecure App. So the whole process fails, and it failed because there are 2 violations. And what we have here is the log4j CVE that's on the screen. So because of that, the whole process failed. But that's something you can determine what happens depending on the policy you're applying to the whole supply chain you see here, or the whole golden path that we are talking about. If the source scan was okay, then you go to the image provider step. That means building the actual container, and then you can scan that container as well. So that's the second scanning step that you have available in this whole supply chain we're looking at. The approach with the supply chain is also that we can cover a lot of different use cases. It's polyglot. It understands different programming languages, and depending on the policies you're defining, you can cover a broad range of cases, different applications, etc., etc. So there's some overlap with let's say traditional CI/CD, but it's a little bit of a different approach. The other thing that's different here that is we're using Kubernetes constructs to make this work. So it's not really like orchestration what we're doing. We don't have a central orchestration that is orchestrating this whole workflow. No, we're doing something called choreography. That's always a difficult word for me. Using a open source project called Cartographer. And what we're actually doing is we want to have the desired state for this whole supply chain you're looking at. So that's what we're doing, and it's in the desired state if we are passing all the different tests, if the image is okay, etc., etc., etc. So that's what you see. Is what you
and maybe
see
good to know. So there's not hundreds or thousands of pipeline instances for specific applications. There is a high-level generalized path to production for all these applications, or for maybe 2 or 3 or 4, depending on specific types of apps. Like every company will have like families of apps, of course, different languages, but also maybe different generations with different requirements. But ideally, you'd have like a couple of these paths to production, which you can also refactor, right? Yeah. Instead of having to go back into, I don't know, hundreds of pipelines and fix something, tweak something. So, yeah.
Yes, so we've now learned how we actually build the app from source to the end result, production. The step before that is, of course, if you are in your IDE, what can you do there? So we also integrate with your IDE of your preferred IDE. This is Visual Studio Code, but we also support
IntelliJ, of course. Yeah. In this space, probably maybe a bit more popular, but who knows?
So, and what we have running here is called Tensu Live Update. So that's a feature or a plugin, an add-on to Visual Studio Code in this case, or in this example. And that means that you can actually change your application, do updates, and you will see the result of that immediately, but then running on Kubernetes in a container as a Kubernetes app. So let me check which app we're talking about. This is the wrong one, I think. No, I need this one. So the app is now saying greetings from Tenso application platform to DevOps. So let me add to the application here in Antwerp. Save it. Save it here as well. You see already some updates going on at the bottom of the screen. It will take about 10-15 seconds. It's now reloading. And there we are. And our Kubernetes app is live updated almost instantly. Let's say 15 seconds. So that's pretty nice. And in that way, we can really see how our app is doing on Kubernetes. So we're using build packs here. We're just updating the container on the fly. And there you have the new result. Of course, you can then choose to commit this update to your, let's say, production version. This is a simplified scenario, of course, so we will sync it to our GitHub repository. And that means that if we go back to the Tenso application platform interface, that what I would expect that the app here in this dev namespace will get an update because the Git repository is updated. Then it will take a couple of seconds. Then this process will kick off and will build the new version of the app. And for example, you can choose to don't have the scanning and testing in your development environment, and if you're pushing it to another environment, you want to add the testing and scanning, for example. Now, let's see.
And it's worth repeating, I think, that this pipeline can be triggered by source code change. It can be triggered by new build packs that introduce patched versions of OSs, patched versions of your language runtimes, but it can also be triggered by the injection of a new, the arrival of new CVE descriptions, right?
Exactly.
Yeah, you can basically, in the simplified version of this platform, come back the next day and see that there were like 2 extra runs because they were triggered by new CVEs.
Yeah.
And so that gives strong guarantees, inherent guarantees about the quality of the app, right?
Yeah. And what we see here, source provider, a few seconds ago there was an update, so the process is kicked off again, is started again, and we will get a new version of our application. Okay, so that's great. So we now have learned the app, who's working on it. We've talked about documentation. We have talked about this process, how the app is built and delivered. But before that, we need to have something to get even started with this app, right?
Yeah. So everyone who doesn't know start.spring.io. Okay, so so that's of course Josh Long's favorite URL, the place where you automatically, or where you can quickly start your Spring application by asking for the right dependencies and the right capabilities, and get basically a curated, templated start to your project. So in this case, on that same technology, we've built basically a start.spring.io that you can customize towards your own organization, and that is a powerful concept, right? In first instance, okay, it sounds like templating. This is not such a good, so this is the template actually that generated the application that we were looking at. You can customize a couple of things, right? You can give it a new name. You can select a build tool. In this case, you can ask whether or not it compiles natively. There's also support for GraalVM and native builds. You can select your Java version, and then you're off to the races. And this will generate, of course, an empty project. But what is really important about this, and I think this is one of the stronger aspects of this platform, is that this is the place where you shift a lot of your conventions, your safety, and the ease of working, and your architecture to the left, right? This is the place where you can actually do architecture, create starters that apply to the conventions of your organizations that already have, for instance, the right styling on board for web apps, or the right libraries and integration and configuration to immediately integrate with your identity provider or single sign-on solution within your organization. You can do this for different this is a little snag here. Yeah. So you can do that for different types of applications, for different languages. There's by default starters here for .NET, Python, you name it. But this is an important part. If you fill these in the right way, you will be ensured that every team in your company starts in the right way, under architecture, and you will be able to not only speed things up, it's an accelerator, but probably much more importantly, get more unity into the architecture, and make sure that there is less to no variation in how to deal with company conventions in your projects.
Yes, and the accelerator is there, and in this case you can download the zip file, upload it to Git, but we also provide the option to directly push it to Git and get started with it.
Yeah, and maybe it's good to show the workload.yaml, which is the starting point, actually, the only interface in
the only Kubernetes stuff in this case the developer has to know, right?
Yeah.
Because that's in here. That's it.
Yeah, this defines the application. This tells to the system like there's a certain workload type. Basically, that maps to a path to production. So, web is the name of the path to production, the supply chain that we showed you. You could have several. You might have different ones for GUI apps or for different languages. There are a couple of other indicators. Here you specify that you specifically want Java 11. So Knative, which is the runtime, is instructed here to not scale down to 0. And this is a bit of an aside, but Knative, we'll get back to it later in the talk. But that's one of the takeaways. If you're never going to use this platform again, Knative is something to study, but it enables us to deploy in the way that we do and have a mature concept around deploying applications onto Kubernetes.
Yeah. And with that, we are at the beginning of the demo now.
Yeah.
Well, actually, if you tell it backwards. So, a couple of slides to provide a bit more context. So, let's go here and that one.
Yeah, so we've seen that specifically for Java apps and for Spring apps, this platform adds value as it does for a lot of other language types. But here specifically, we can hook into, we get all the benefits that the Java build pack brings towards creating a really good container for a Java app. It knows about all the idiosyncrasies of Spring. It has automatically enabled a lot of little features that make Spring apps and Spring Boot apps behave better in a container. So probes for liveness and readiness, all of these little things about shutting down the right way that make the container function right. We've seen that at runtime we can easily reference the output of the actuator and have insight into the runtime characteristics. And it's basically enabled us to go from a little bit of Spring source to a running app in a quite professional production capacity. Right?
Yeah, yeah.
So, so basically this platform, I was at the customer recently discussing this, and he said, like, what I want is a machine where I can build my own golden path without me having to build that machine. And this is basically what it is. We have here an application platform that can codify a golden path. I think that the golden path is maybe a familiar concept to you all. So sort of coined by the people from Spotify to describe the situation where giving every DevOps team unending freedom to make their own choices is great. And, I won't say but and, and it leads to a lot of variation, that's one thing. It leads to a lot of reinvention of wheels, but it also leads to situations where probably operators of the platform are less or not able to support some of these choices. And more responsibility is put upon the team, which in some cases is not really adding any value. So Spotify started with describing what is the supported path for a certain type of application, which choices get you in a comfortable position that you don't have to do all kinds of ops work, and totally optional, of course, except if you've read the June books, you will know that the golden path was basically the only way for humanity to not get extinct. So it's optional, but yeah. And we've seen what this all brings. So there's a whole integrated platform. This is also about simple developer experience. Basically, drop the code in, get a running app out. It also works across Kubernetes clusters. So this is a simplified version, but you could have like chains of stages that even cross different infrastructures or different clouds. It runs just as well on EKS and AKS as on our Tanzu Kubernetes or on OpenShift, if that's your choice. It's all automated in the supply chain that you saw. There are, of course, implementations underneath, and you have choice there. There are different scanning options that you can use. We use, in this example, open source options, but if you have an investment in Sneak or some other, or Carbon Black or some other security tool, it can easily be slotted in, or you can make your own custom integration of one step that you really need to do in your path to production. The integration is super light, so this is not like a huge programming project. Basically, the coordination between the steps is super light. It's just catching the output and putting it into the next input. So, yeah.
Yeah, and the way we look at it with Tensor Application Platform is actually according to the steps you see on the screen right now. So, on the left side, we have the process for the developer called the inner loop, and this is about learning how he or she should get started with the platform as it is, but also with the applications that are on the platform. So there's also we didn't show that today, but there's a learning center that can customize. It can be customized, that helps developers to get onboarded to the system, but also with the accelerators you saw, the documentation, also to get started with the apps that are in your organization or the company where you're working for. The inner loop means also that we can do we can iterate, we can build the app, deploy it to Kubernetes, see what the result is. After that, commit it, and then you have the outer loop at the right side. And of course, this outer loop will be more or less managed by a SecOps team that will think about, okay, what are our security policies? Maybe how do we test? Do we have any specific requirements when we're talking about building containers? That's something you can configure and customize if you would like to do that. And what we've seen today, if we look at the actual implementation we use today, then you see some logos on the screen. We have the inner loop on the left side. Developer in our demos working on Visual Studio Code is using build packs to really test the app in a very fast and convenient way. Commit it to Git, and then the other process kicks in and goes through the steps of the unit and integration testing, the source code scanning, the actual build of the, let's say, production container, scan that again, put it in a registry. In this case, you see Harbor registry, but it can be any registry. And then at the end, the application is deployed to a Kubernetes cluster or to more Kubernetes clusters. The solution Tensor Application Platform is built with what we call an open sourced first mindset. So we're using open source tooling that's available in the market, combine that to a working solution, support it, and you know that it's working. We're using Backstage, that's quite popular nowadays. We're using Carvel, we're using something called Cartographer that is responsible for the whole supply chain you saw during our demo, and many other tools that are available. So the Tensor Application Platform comes with a default set of tooling, but excuse me, but of course you can swap in, swap out tools if you prefer other tools to be used in the whole supply chain. So what are we actually solving with this? So a couple of things, and of course we solved that in the demo, I think. So for example, onboarding experience is something we're solving here because we provide the internal developer platform. We can think about inconsistent CI/CD flows. We provide a common path to production that you can tweak and customize using the policies, but it's a common path that you can use. With the build packs, we provide a new way, a more optimized way to build containers in an automated way, stepping away from the Docker files, and some other things you see on the screen, of course, here. So this is, as we talk about this solution Tensor Application Platform, it's really about providing a app platform where app teams and platform teams work together to provide an environment that helps you to build your apps in an automated and secure way, deploy them to Kubernetes, and make them ready for production. So that's what this is about.
And I would say one of the aspects is also the fact that the different disciplines and different teams, this whole platform is designed in a way so that they can do their work without interfering with the other teams. I mean, of course, interaction is great, but it's also great if you're not clobbering each other's work. So all the roles have a specific place where they can express their concerns, being it the CISO and security engineers that can have concrete places where they can implement their security concerns, be it in the accelerators or in scanning policy, whereas application teams don't need to be burdened with that and create business value and just keep going fast.
Yeah, okay. So you might think, so I want to test this solution. Are there any options? So the answer to that is yes. We have the tab developer Sandbox that's on the Tenso Academy website. The URL is at the bottom right of the slide, so that might be something to have a look at. And maybe you are not the one that will be building and maintaining this platform, but it might be interesting for you to see how it works for you and how you can consume the services that are offered by Tenso application platform, and maybe it's worth a discussion with your colleagues internally. Hey, we have seen this. This might be interesting for us. So feel free to have a chat. We have a booth down here in on the exchange floor. So we're happy to have a chat about Tenso application platform with you. Apart from that, let me click these. So we're from VMware, as you already noticed. Some other thing we're talking a lot about with our customers, for the customers for who this is applicable, is about support, Spring runtime support. A lot is happening there. We're, of course, we're moving to a new version of Spring, and we provide extended support for companies that are not ready to migrate to Spring 3, are still on 2.7. So VMware provides an 18 months of extra support there. We have a nice platform called the Spring Academy. This is a learning website with a lot of nice trainings around Spring.
And certifications.
There's both a free offering and a paid offering. And the last thing is, if you're talking about migrating to the new version, then from VMware we also offer Spring migration consulting. So it's the third thing. Yeah.
Yeah.
Having said that, now it's time to introduce ourselves because we're doing the best backwards, right? So who are you?
So I'm David Caron. I'm a Tanzu solution engineer in the Netherlands. We'll be at the booth later and tomorrow morning if you want to chat about anything. Also, our other Tanzu colleagues will be there. Also, people from from the Spring Academy will be there. You might run into the occasional Spring developer advocate or committer, who knows?
Yeah. And my name is Victor van den Berg, also from the Netherlands, and also part of the Tenso BU, focusing on the Tenso application platform and all the solutions we have in the portfolio. So that's it. We have 7 minutes left, so I think there's time for some questions, if there are any. So feel free, if you have a question, we're happy to answer those. And if not, then we thank you very much for your time and for being here.
Yeah, because we're between you and beer, obviously. So, thank you for your time. And,
have a nice evening.
Great conference.
Yes.